All right. Can hopefully this works. Hopefully my laptop also stops trying to freaking blast off into space. Yeah. I would like it to not do that. But we'll just have to settle for what we have to settle for. All right. I am alive. I am alive. I am alive indeed. All right. It's time for the very serious, very not sketchy synthesis, and I didn't even get a new bucket. Everything's still dirty. I don't know what I'm doing. I just had to bike like half an hour to Home Depot. Hi, Warpy. Is the windy sound in the background your laptop fan? Yep. It's trying to be an airplane. It's cosplaying. My laptop is cosplaying as a freaking jet plane, and I don't know why. But last time it went away after a little bit. I tried to like prop it up so it gets airflow. We'll see if that works. Hi, Warpy. Hi, Tsuni. Hello, anyone who is still here. All right. So, first, before as I sort of organize things, I do want to tell you about why the stream was so late, which involved me getting where is it? This gigantic gallon of acid from the hardware store. Hi, Dan. We are live. Yeah, so I got this gigantic gallon of acid from the hardware store because I realized I need it. That's not... It didn't leak, did it? Uh-oh. I don't think it leaked. Well... I mean... Yeah, it's not... That's kind of sketchy. I feel fine. I think everything's fine. Okay, I think I think everything's fine. I think it's not leaking. But what happened is my original plan was to use a chemical called potassium permanganate. Yeah, I sure hope so too, given there's a freaking gallon of it. So my original, basically, what we're making is, HAWK TUAH, HOC2. Finally something good. I know, A the Astrologer was so good. And if anyone saw Syzygy Altair, is normally she's Z the physicist VTuber. But today, she was A the Astrologer, and it was amazing. But that already happened. Now it's time for HAWK TUAH. So what we're going to be making, the chemical we're going to be making, as you might have guessed from the thumbnail, is called Holmium Dicarbide. So holmium is symbol HO, carbon is just 2, so HOC2, as in HAWK TUAH. I literally was just looking up like random papers on holmium compounds because holmium's this weird obscure element that I have some of. I have some of just the metal, and so I was just looking up. Some people were mentioning this dicarbide. I'm like, wait a minute, there's a HAWK TUAH, synthesize that thing. So that's the plan. The basic idea is we're just gonna mix graphite, which is carbon. It's like this the most obvious reaction. There we go. We're going to mix graphite, which is carbon, and we're going to mix it with holmium metal. So this is what holmium metal looks like. Let me see if I can give the camera a little bit of a better view. It just looks like a grayish metal. There isn't much to it. But yeah, it's this weird obscure element. It's used a lot in lasers that we use on people's prostrates. It's a thing. But yeah, super obscure, fun element. Hopefully we'll make a even more obscure compound with it, which is holmium dicarbide. But the way we're going to detect that, like, how do we know that we actually made the holmium dicarbide? Well, if you put it in water, it releases a gas called acetylene, which is, it's basically hydrogen dicarbide. Something like pencil lead. Yeah, exactly like that. So basically what we're going to do is, the idea is you just mix holmium and carbon and heat it up a fuck ton, and that gives you the dicarbide. You're gonna have this stream in the background while I play a game. Feel free to. Yeah. And then we'll just mix them, get them mixed, and put it under super duper high temperatures. The convenient thing about this is one of the things we're mixing it with is graphite, and graphite turns out to be really, really good at absorbing microwaves. And so if we put it in the microwave, like, if you put graphite in a microwave, it gets to like 2,000, 3,000 degrees Celsius. It's crazy. So that should be enough to heat up our, the graphite will absorb the microwaves, get crazy, crazy hot, heat up our reaction mix with the holmium, and that will give us the holmium dicarbide. And that's only step one, because now we have to prove that we actually HAWK TUAH. And the way we do that is first we mix it with water, which makes acetylene, and then we have to somehow bubble that acetylene gas into some sort of liquid that will test for acetylene. And since we're going to be making such a small amount of it, the only feasible way to do this that I can think of is have some liquid where when it mixes that, like, something in the liquid reacts with acetylene gas to form some, like, solid, which we'll see the solid precipitate out. What I was going to do was use potassium permanganate, because everyone on the internet said you can get it at, any pharmacy, and it's this easily available thing, and it's great. It's great. It reacts with acetylene, makes it precipitate. And I go to the pharmacy, and there's only one pharmacy that I could think of, and they don't have potassium permanganate anywhere, so yep, no potassium permanganate, can't use that. So we get to do the stupid route, the really, really stupid route. Here's the plan. First, we're going to get, last time we used this is copper sulfate in the form of pesticides, or root killer? I don't know if it's actually whatever. It's a thing I got from Home Depot, and it's copper sulfate. It's copper 2 sulfate. So metals can be in different, like, it's because they're called oxidations. It's basically how many things they're bonded to, right? So this is copper with sort of like 2 bonds coming out of it, you can think of. It's copper 2 plus. So this is copper 2. There's also copper 1. What we want is copper 1. So what we'll do is we'll mix it with sugar, like fructose, like the sugar that's in fruit, and that should reduce it to copper 2 oxide. Then we'll take the copper 2 oxide, treat that with our gigantic gallon of acid that hopefully isn't spilling, and that will give us copper 1 chloride, because we've switched from, the sugar has reduced it from copper 2 to copper 1, and now we can make copper 1 chloride. Then we can mix that in solution with ammonia, bubble our acetylene through that, and that should form a precipitate of copper 1 acetylide. If you know about metal acetylides, you will know that copper 1 acetylide is a thing that goes boom. Now, thankfully, it should really only go boom when dry, and we're never going to have it dry. It's always going to be, in aqueous solution, if we actually do successfully make it. But that's the plan. That's how we're going to be detecting it, is by turning it into a boomable chemical. Apparently not yet. Guideline strike. Oh yeah, so let's show off the other things we need. This is some delicious fructose sugar I actually got for a totally different project, and was very excited. I finally had a use for it. Why can't I camera? There we go. There we go. Some delicious fructose sugar. So this is like fruits often have a lot of fructose. I do not know what is happening, or there we go. I cannot for the life of me position things under a camera. Okay. And then we also need ammonia. Now this is where we have another stupid problem. Thankfully, the ammonia did not go flying. I'll talk a little bit more about the going flying a little bit. It's lemon-scented ammonia. I'm not even holding it the right direction. So hopefully that doesn't... As you can see, the chance of this actually working are the chances of us making the dicarbide, I think, are pretty high. I think we're quite likely to actually make the HAWK TUAH. But the chance that we'll make the thing that go boom and successfully detect it are sparingly low with our hardware store chemicals that are lemon scented. But we're trying anyway. We press on. And to get the acid and the ammonia from Home Depot, because again, I was planning on using potassium permanganate for all of this, and I was planning on using potassium permanganate from the pharmacy for all of this. And when I figured out that I couldn't, I did not have much time, and I had to bike half an hour out to Home Depot, go walk a little bit, and then go to Home Depot. They freaking hid it from me. They tried to hide. They knew that I'm going to do the sketchy shit with it. They tried to hide the acid. It was like in the bottom, behind a rack, behind a like ladder thing, like still in boxes, but they can't hide from me. You can't hide from me. I will find all my acids and bring them home. And so yeah, I just put them in the bike. Had to bike back through the snow. It's fucking snowing in April. What a nightmare. So it's cold, it's windy, it's snowing. And yeah, I did it. I bike back, and I'm it's like bumpy, right? And all of the giant gallon of acid is just sitting in my thing, and then I'm it's bumping and bouncing up and down. It's fine, and I'm like, everything's fine until the very end. Literally, when I'm like bringing the bike up to where I go like dock it, I go up the curb, freaking cartoon style. The thing goes like flying out. It literally went like boing. The giant gallon of acid went flying, landed on the concrete. And I docked the bike and very nervously looked at it, and it seems to be fine. It's definitely kind of crumpled and shit at the bottom, but as long as it doesn't leak acid everywhere, it's probably fine. It's probably fine. It's probably fine. Anyway, that's the plan. I don't have any proper equipment. I don't know what I'm doing, but god damn it, we're gonna do it anyway. In fact, we don't actually really need this yet. We don't need the sketchy bucket yet. We need the microwave. The microwave. So let's get rid of the sketchy chemistry bucket. And we're going to need some fine particles of our holmium metal. And we're going to need some graphite. Now, the sensible thing to do would be to have gotten graphite from Home Depot, but I didn't think of that and am an idiot. So, instead, we're getting graphite from pencil lead. This was my original backup plan in case I didn't get graphite anywhere else, and I didn't get graphite anywhere else. So it's horrible. It's probably going to be full of lots of flux, and it's going to make lots of smoke. But yeah, so let's get this freaking HAWK TUAH started. What a crazy disaster this has been. All right, let me get pencils. No. Thankfully, I have a bunch of pencils. Got a bunch of pencils here, so yeah, these are our reagents. We have metal plus pencils equals HAWK TUAH, and well, metal plus pencils in the microwave equals HAWK TUAH. That's the plan. So I guess we just break these. Where is it? Where did the lead go? What the fuck? Oh. Did just a piece of it go flying off or something? I don't know what I'm doing. Have I made it obvious enough that I don't know what I'm doing? I keep snapping bits of the lead off. It's okay, I have an X-Acto knife. I can do it that way. Let me grab my knife of the X-Acto. I thought I had an X-Acto knife. Did I hide it from the freaking dorm people? Oh no, it's right there. It's right there. It's right there. Who needs a cutting mat when you have a cardboard box? We're good. We're so back. Yeah, acetylene is used in welding actually, I think. The gas, but we're not really trying to make acetylene, even though we are eventually, just indirectly. We're trying to make HAWK TUAH. So that's yeah, and it was just a mess. Like I was out in the middle of nowhere. I was literally out in the middle of nowhere to go to the Home Depot to get this shit. And there's just some random like college kid in a bike helmet buying a gallon of like concrete etching acid. Why is it hard to get how is it this hard to get the lead out of a pencil? Yeah. So the thing is I'm going to be doing this inside my microwave furnace, and the microwave furnace's walls are made of graphite. So I could just like pour it onto the walls. That's a bad idea, but it is a thing I could hypothetically do if this turns out to be the disaster that it's seeming to prove to be. Okay, maybe I can do it now. There we go. See, we got our delicious carbon right there. Delicious, yummy. I'm not strong. There we go. Our first bit of reagent. A tiny piece of carbon that you can't even see. Stage 1, pencil chopping, exactly. Stage 1 is chopping pencils. Stage 2 is microwaving. Did I just fling a piece? I'll find it. Oh, there we go. Yeah, stage 2 is microwaving. Stage 3 is mixing a bunch of Home Depot chemicals and stage 4 is making things that go boom. I don't want to get in trouble with YouTube, okay? I can't make it that obvious. Come on. Can I just do it this way? What happens if I do it this way? Ah, yes, a cardboard box, the perfect work surface. Nothing. Okay. I mean, the thing is, we're not actually trying to make that much of it, but we'll just have to see how this goes. So I should note, by the way, the reason we can't just... You might think, like, okay, well, why can't you just look for bubbling from the acetylene? Is because holmium is what's called an electropositive element, which, in this case, it's not exactly what it means, but in this case means it reacts with water to form hydroxide. So, if what's going to happen is, this conversion is not going to proceed perfectly. There's going to be some leftover holmium metal, I'm pretty sure. And that's going to generate hydrogen gas. And so we need some way to distinguish between acetylene and hydrogen. So that's what the thing that go boom step is for. I need to come up with an alternative way to say that. Energetic. The energetic step is for. See, it's just energy. It's not scary. It's just energy. Come on, you piece of fucking shit. You dipshit. I did not go all the way to Home Depot for this. For pencils to be my enemy. I mean, this is making such a mess on the floor that I'm going to have to clean up now. At least, I mean, look, better mess of pencil lead than mess of, like, corrosive chemicals. But my standards have gone out the window. I still can't believe my roommate hasn't, like, reported me. Maybe after this. Maybe this will be the last straw. How is this hard? This should not be hard. Can I do it into the thing? Nope. That doesn't help. I sincerely thought this would be like a two minute at most process. What am I doing? Is their technique? Do I not know the secret pencil chopping karate technique? You know how tempted I am to try to like dissolve away the pencil in my newly acquired acid. Okay, this is a clean cut. This is what we want. Now we can just peel away. Peel away the wood. Why do they make pencils so hard? Like, come on. This is America. You should be like making everything as cost cut as humanly possible. Don't be making like nice materials. Yeah. It's okay. I'm busy embarrassing myself on the internet. Yeah. Okay, now this is not. Now this is no easier than the other ones were. Knife time. Knives solve so many problems. It's amazing how many problems knives solve. You just get the knife and then so many problems just go away. It's amazing. All right. There's some graphite, and again, this is not even good graphite. This is graphite full of like flux and nonsense that will make tons of smoke and fill my lungs. But if you think I have any sense of self-preservation, then you're right. I have some, but not much. There we go. This is what I wanted. Little bits that I can just pull out. There we go. I don't know what the wood is going to do. Hopefully not burn. What if this burns? I really hope it. I'm just going to hope it doesn't burn. Is that a good technique? We're just gonna hope. Okay. Now let's get out the furnace that we're going to be doing in a sec, which is even more sketchy. This is where things get even sketchier. Okay, I have a terrible idea. Yeah, I have a deeply, deeply awful, horrible idea. But I might do it anyway. Are you ready to hear my deeply horrible, awful idea? First, we need gloves. Gloves are the first step in the deeply horrible, awful idea. Okay, so this is the bottom of my microwave furnace. As you can see, it's not doing great. This, yeah. This is the top of my microwave furnace where the graphite is. It's doing all right. So can I just use this like a bowl? Put holmium towards the side and form the dicarbide? Then I wouldn't need to faff about with this pencil mess that I just made. I mean, I might put some in there anyway, but like, graphite, right? Graphite. Sure, let's do it then. Let's do it. We're doing the easy, simple way and not the correct way. Because come on, why would you do the correct way? Let me wait. Well, I'm a little miffed that I filled the covered our floor in pencil shavings now, but it's all right. It'll be all right. Let's try to. Let me get my other glove on. I'm also out of like my actual thing of gloves, so I have this sketchy bag of gloves that somehow airport security didn't mind. Everything about this is just the sketchiest possible option. How are you making what you made with a microwave? How are you verifying the thing that you made? Go boom. Just to clarify, we're not actually having it go boom. We don't want it to go boom. It's just a thing that can go boom. We're looking for the formation of a solid. And it just so happens, rather inconveniently, that that solid can go boom. All right, so let's try to keep the shot in, but pour out the little fibrous, I don't know what you would say. How soft is it? There we go. Let's just pour some in there. Wait. Alright. Yummy holmium. Holmium. It's named after Stockholm. That's why it's called holmium. Alright, the softness test. Is this a soft metal? Not really. It's not really all that soft. No. The annoying thing is that I can tell there's a bunch of like dust at the bottom from me just going like this, and in transit it's just going like this. Hi, I caught you live. Let's go. Hi, Z. This is such a creative idea. I'm glad you think so. This is it's an idea. I was literally just like reading about, because I got this vial of holmium. I got a bunch of they're called the rare earth elements, are like at the very bottom of the periodic table. No one appreciates them. No one gives them the love they deserve. So I'm like, it's a little echoey. I am doing this in a corner of a dorm room with the audio coming off my laptop, so I can't use the audio off my phone, and I don't have the microphone because I didn't have time to go to the library to get steal their microphone, so yeah. Sorry about that. There she is though, yeah. So hello, so everyone say hi to A the Astrologer, now that A the Astrologer is in chat. But yeah, I was just looking up like, any fun holmium compounds I can make? And I saw holmium dicarbide, and I was like, wait a minute. HAWK TUAH. So, who needs a ball mill? If this is actually a fun little learning tidbit. One of the things you do a lot in material science is you use a ball mill, which is literally like this, but all made of metal. And so, not A the Astrologer. Hi, A the Astrologer. How are you doing? What you basically do is you have something that you want to grind and like super duper strong balls made of like usually some kind of ceramic, and you put them and you just spin it like this for days and days and days, and as the heavy super hard balls smash into your stuff, they slowly grind it down. So this is like a really shitty version of a ball mill where we're not doing it for days. They're called the media, like the big heavy balls are called the media. The media is just the thing itself, and everything is just wrong, but hopefully we have enough holmium dust here. Now, I've worked with samarium before. That was my very first stream. Used also a rare earth element that nobody appreciates, which was samarium. Let's just dump this all out and see what happens. And I remember for samarium, it said that small pieces, like small dust pieces, are extremely flammable. So, I don't know. We're just going to hope that that's not the case for holmium, because I don't remember seeing that anywhere. I have no idea how it would be the case for one of these rare earth elements, but not the other, but we're just gonna hope. Okay, let's get some of that dust on there. So this is our element holmium. And the thing about the rare earth elements is they all behave mostly similarly, but their main application is for like lasers and stuff that involves electron transitions, because they have this sort of really weird electron geometry where some of the electrons are like shielded from others. And so you can get things like fluorescence, where if you hit it with a, like if I were to dissolve this in water and turn it into a chemical and turn it into crystals, then what would happen is you could like hit UV at that solution and it would glow a different color. And the different rare earth elements will glow different colors. So even though like each element individually is not that useful, they like each have specific niches based on the different electron transitions that they do and the different wavelengths of light that they emit. So the different elements will emit different colors. So there we go. There's some mildly fine bits of holmium dust. It's not much, but we'll see how we want to do this. I mean, I can put some large pieces in too. I'm not using all my holmium on this project. Maybe I can grind it against each other in my hands. Will that work? Yeah. Okay, wait, that's actually kind of working. Because it's not a super hard metal. It's not freaking titanium. But it's also not like sodium, right? Sodium, you can like cut like butter. It's not that. But it should be a little bit softer. Soft enough for me to kind of grind it against itself, I think. But all I'm really doing is just dumping big pieces in now, so who knows? Who knows? It's almost like I should actually have ball milled this in a real ball mill, but I don't have a ball mill. So you can build them. There are, like, again, it's not that complicated of something. Ooh, this is cool. I'll stop calling you A, the astrologer. Yeah, the lanthanides are really fun. I think they're really cool, and I'm going to be making more videos, because I didn't just get one. I didn't just get holmium. I also got samarium, which I was going to use for the previous video. I got praseodymium, which is used for making glasses for glass blowers, because if you mix praseodymium and neodymium, these are two rare earth elements, which for a while we thought were the same element, which is kind of fun. But if you make this mix of elements, again, like the different elements have different wavelengths of light that they respond to. And what you can do is you can put it in glass, and it will block out the sodium emission line. What's the point of this? Why do you care about blocking out sodium's emission line? Because when you're glass blowing, glass has lots of sodium ions in it. It's just blinding. You can't see anything from all the orange light from the sodium. You mix together praseodymium, neodymium, and you put it in glass. Their specific transitions will block out that light, and you can see what you're doing. So it's really cool. Yeah, let's just... Again, we're not really doing this correctly. None of this stream was ever going to go correctly, but it is kind of going more incorrectly earlier on than I thought it would be. It's alright. It's alright. I wonder if there's something I can crush it with. Like, just get a heavy object and smash it. Smashity smash, smash, smash. Super Smash Brothers. Let me find something heavy. Heavy. I do not have many heavy objects in my dorm room right now. But, come on, there's got to be something here that's just like a thing made of metal. There is a thing made of metal, but it's radioactive, so. And I spilled my fructose on the floor. Oops. Look, there are worse things for me to spill on the floor, okay? At least I spilled the edible sugar on the floor and not the acid. This does not bode particularly well, but it'll be fine. It'll be fine. Don't worry about it. Okay. Crushing. It's crushing time. Oh, I can use my freaking blade of the X-Acto knife. Perfect. Perfect. That's exactly what you're supposed to do with the blade of your X-Acto knife. And then you put it against your phone charger, and you need kind of the thing is I need a hard surface on both sides is the problem. And I don't want to like break off a blade or something. How do I want to do this? How do I want to play this? I have not played these games before. I haven't played these games before. Let's see what happens if I just... Okay, that actually does kind of work. I can kind of just smush it. So maybe that's what I gotta do. I gotta just smushity smush smush. And fling holmium into my eyeballs. It's not that toxic, it's just a metal, but again, it does like react with water and stuff, so it's not exactly something I want to get everywhere. This is not working. My plan has failed me. I will try using my charger as a hard surface. It's almost like ball mills were invented for a reason. I thought there was more. I honestly thought that I made a lot more dust than I did, but that's alright. It'll be alright. She'll be right. Let me see how I can play this. Yeah, let's just do it. Let's just go for it. Let's just go for it. Because the thing is, maybe the high temperatures will break it down a little bit too. So what we can do is just give up on any sense of correctness, give up on any sense of doing things properly, and just shove a bunch of holmium into the corner of your furnace. Where the graphite is. And hope that nothing goes horribly wrong. Now, there's another little risk of this, which is holmium will form an oxide, especially at really high temperatures. We're not doing this in anything that reacts with water is not something to mess with. Yeah, generally. I mean, there's varying levels of sketchiness. This is not particularly sketchy. But yeah, like calcium metal that reacts with water is very bad. Probably the worst thing that reacts with water that I can think of just off the top of my head is like germanium halogen compound. So something like germanium tetrachloride, what'll happen is it reacts with water to form two things. It forms hydrochloric acid, which is what this is, and so it'll form like acid inside of your lungs, and it also forms germanium dioxide. The germanium, the chloride part of germanium tetrachloride turns into hydrochloric acid, and the germanium part turns into germanium oxide, which is like sand basically, and your lungs fill with sand and acid, and it's horrible. This isn't very, on the scale of reactions with water health-wise, this is not that bad. But I was going to mention some other vaguely safety-related thing. Oh, yeah. So the way this is supposed to work is that the carbon just reacts directly with the holmium, and we get the carbide. But some of the holmium is going to have been oxidized by this point to holmium oxide. And the carbon can react with that, too. It's something called a carbothermal reduction, where it will reduce it back to the metal, or even the carbide directly. Which is good, that's what we want. But the slightly not great thing about this is that this process liberates a little bit of carbon monoxide. So, again, ventilation important, do things safely, small scales, and we'll see how this goes. But yeah, it shouldn't be a huge problem, just because I have pretty adequate ventilation, thankfully, and I'm working with such a tiny amount of the stuff anyway. Again, like even of the amount here, the only stuff that's actually going to react is stuff that's in contact with is what's in contact with both. Like the parts of the holmium that are in contact with the graphite. So I might want something to like hold it, like to tip it this way. We'll see. We'll see what I can do. Let's alright, let me try not to dox myself here. Up diddy goes the microwave. Yes, I know you can't see anything that is intentional. Now I need, yeah, I want something to like prop it up a little bit, but I don't know what will not be obliterated. But I don't know what will not be obliterated by the microwave. So let's see, what can I use? What will survive the bajillion degrees of the microwave? Maybe I'll just sort of shake it down, and we'll call that good enough. So in that will go. And now, take off one of my gloves. Do what you never should do, which is reuse them. I'm so sweaty. Okay, let me actually get some filming action here so that you can see what's going on. This is the frickin', I know this is the frickin', what is it like on spaceships? Like sometimes there's a zone where like you can't see anything. Okay, wait. There we go. That frickin' piece of shit. Okay. There we go. Now it's upside down. Now you can see the microwave furnace. And in there is our reaction mix. So let me get my gloves on, and we'll put this little lid on top here. Bonk. I'll put the gloves on properly later. Alright. Now we close the hatch and let it cook. So we'll leave it in there for a little bit. In the meantime, we can work on preparing the reagent that we'll use to test. So will that? Oh God. Okay, wait. I don't know if you can see that. There was sparking at the bottom. Let me Actually, maybe that's good. Maybe sparking is good. It'll get hotter. Actually, some of the papers, a lot of the papers actually made it in an arc furnace. So maybe sparking is actually good. We want it to spark. This is like the one case where you want things to spark. Although I hear weird noises, so sparking may be good. Weird noises probably bad. Oh. I should have turned on the fan. Let's. Yeah. This is so bad. Why am I doing this? Okay. At least we have ventilation now. This is called being an idiot. You generally don't want to do it. It's generally not recommended. Let's see what we can see. It looks fine. Our metal just looks like it's in there. I wonder if it's... What if we do it without the lid? I wonder if it's this junk in the lid from when I borked it that's making all the smoke, because that might genuinely be the problem. That might genuinely... I cannot aim this camera for the life of me. It's upside down again! Oh my god. This might genuinely be bad. Let's just see how this goes. Oh, frickin' frick shit. I don't know if we can see in there. Last time it sparkied. I don't see any sparks right now. This is really not an ideal way to do things. Oh! There's a little blob of burning. Haha! We're doing it. We're doing something. It is not easy to see, but there's just a little blob of burning orange. We'll leave it there for longer, I guess. Something's happening. I wonder if it's the powder micros, because it looks like it's not actually our sample that's doing the burning. Maybe it is. I don't know. I don't know what's going on. Let's take a peek in a little bit to see if we can scientifically deduce what is happening here. And now it smells kind of weird. Ventilation is your friend. Alright, let's see if we can inspect. Yeah, it has nothing to do with where metal is. It's just this one spot happened to get warm. Earlier. Huh. Funny that. Alright. The reason... Oh, idea. This. Ha! Now, the sketchy burnt part that's probably full of junk that smokes will not get hot, but we can still get to use it as a lid. A genius idea. Truly. Surely. Okay, so we'll leave that going now. I will aim the camera. Okay. So let's leave that to go going. Oh, there's some residual carbon there that's still glowing orange, but it doesn't seem like it's smoking much, so as long as it doesn't start a fire, it's fine. As long as it doesn't start a fire, it is fine. Here we go. Yeah, exactly. We'll see. This is the actual HAWK TUAH synthesis. Normally it takes a little bit, so it is good that we have something to do in the meantime. So let me get gloves back on. Again, don't reuse gloves. I just am an idiot and didn't have time to buy more, so yeah. Honestly, basically anything I do, don't do. That's honestly what you should take away. I'm not here to tell you things to do. Don't follow what I do, but you can still learn things and learn cool stuff. And hopefully this will be an excuse to my frickin' frick. How is it this hard to put it? It's because I was so sweaty. I was so sweaty that now I can't put my glove back on. It's like it knows that you're not supposed to do that. Oh wait, I'm also putting it in the wrong finger holes. Or you can get a live... Why? Whatever, that's good enough. Sure. Glove. Glove. Okay, let's move our Holmium out of the way and put it right next to the radiator. That is a marginal fire hazard, but it'll be fine. Yeah, you can just go in there. There's some Holmium in there too, but whatever. This is junk. My gloves are making noises. Glove noises. And that's not a fire, is it? No, it went out. Okay, well, hopefully that wasn't a fire. I don't think it was. Okay, now, step uno, which I definitely should have tested before, but decided not to, because I'm dumb, is where we return to the bucket of misery. This is just salt. That's from the experiment that destroyed my microwave, which was not on live stream, but if you were on my Discord, plug for the Discord, you know about it. Yeah. I don't know if you can hear that anymore. I have like platypus, like duck foot gloves. my limbs are merging together. Glove noises are funny. Microwave noises I think are fine. It's definitely, I can see a little bit of glowing orange. So we'll take a look at that in maybe 30 seconds. But we'll sort of get started with this. So we need copper sulfate. What we're going to do is mix the copper sulfate, which is this root killer. Mix that with sugar, which should reduce it to copper 2 oxide, which will be like a reddish precipitate. And then we can filter that, which hopefully goes fine even though it's kind of corrosive. And I'm just using coffee filters. But we'll cross that bridge when we get to it. Oh no, my model is fucked. If I'm going to leave my model get stuck out of view, at least it can be in a marginally less fucked position. Okay, let's... inspection time. We inspect. Oh wait, it's upside down again, isn't it? No. Okay, there we go. This is how we want it to be. Now we look at the fruits of our labor. It definitely got hot in there. My eyes. So there's... Oh, I cannot get that close to it. I don't know if you can see that in the camera. It definitely got hot in there, so everything seemed fine. There was some smoke, but it's probably fine. So we'll just leave it cooking for another like 10 minutes or so. We don't do things responsibly here. We do things funnily. Let's do what? 8 minutes? 8 minutes 30? That seems fine. That seems legit. This is so bad. I've gone too far, right? This is just way too much prep and way too much everything for such a ridiculous stream, but it's happening. I'm doing it. I'm not a quitter. I'm in too deep. That's really it. I'm just in too deep. That's all there is to it. Freaking frick. All right. Glove. How do I want to do this? How do I want to play these games? I don't even remember which side this. Okay, well the sweatiness tells me. See, it's actually good. The sweatiness makes you know that makes it clear that you're using the right side if you're reusing gloves that you definitely shouldn't reuse. Okay, let's reuse the other gloves too. Fuck, is that the wrong side? No, it's not. We're good. We're cooking. I mean, again, this just touched Holmium, so this is not that bad. even if I made a mistake. There we go. That's what it's supposed to be. Go on like this. Normal gov platypus freaking duckfoot glove that I can't aim at the camera because everything's in a weird position. Okay, it looks like one of my fingers is like abnormally short, but it's just the glove being fucked. Okay. I'm an idiot. I forgot to get water. We need water. I need water. I will take these. Okay, I'm tired. I'm done. I'm done reusing these stupid pair of gloves. I'm just going to get water and get new gloves, and everything will be fine. So I will be back in a secundo. I have returned bearing the liquid of life. Water. I have the water. Let me get the grooves. I need the grooves and the water. Are these my last pair of gloves? Jesus fuck. Oh no, there's one more. Great. A single other glove. I'm just gonna wear these the rest of the time, honestly. And if I have to touch my phone, then fuck. Yeah, it'll be fine. We'll figure it out. Alright. What we're gonna do is pour out some of our delicious water into a not particularly delicious looking, already used reaction vessel device. Which is definitely not a champagne flute from Target because they were like $2. There we go. Got some of that. I just put it in here. Yeah, sure, why not? Now, we add our frickin' root killer pesticide toxic copper sulfate. Yay. And there we go. Oh, come on, I can't. There we go. Yes, the water is a little green, but it's probably fine. That's just iron, and that shouldn't do anything bad. So we'll just add some crystals. Some delicious blue crystals. I love blue. I love working with blue crystal chemistry. That was probably too much, and I'll have to deal with decanting it off. Did I put the lid on properly? I think so, okay. Now we wait for it to dissolve, which would help if I had something to stir it with. Do I have something to stir it with? I can probably use plastic. I can't use metal, it's corrosive to metals. Do I have a plastic stirring implement device? That is the question. That's Shakespeare right there. Wait, is the bottom of the furnace glowing? What the hell? Okay, I don't really know what's going on over there, but hopefully nothing, like, goes wrong. I found this old janky piece of a 3D print that I put holes in with a hot glue gun. This is now our stirring device. Is it a good stirring device? No. Very no. How do I stir it? I forgot that I have to stir things. Can I use a pencil? It's not made of metal. If it's not made of metal, it should be fine. Okay, here's what we'll do. I'll pour it into this and back. See, it's like bluer already. chemistry. I wish I could position my camera in a way that I would not be like a PNG tuber half of the time, but such is the nature of my current not particularly nice setup. Is that more blue? That seems green now. I did make green iron sulfate in this before, but I don't think that should precipitate out. How is this already going so wrong? Like, seriously. I've barely done anything yet, and it's already the wrong fucking color. Oh, the hole in there is just the light coming out, because there's a hole in the top of the furnace. Now there's a hole in the bottom of the furnace. It's supposed to be to let, like, air and smoke escape. I arrived! Hello, hello, hello. You are in for, me being very stupid. So we have the microwave going right now, the microwave furnace, but, like, upside down and making weird noises. It's kind of, I don't think it's on fire, but it's close. And that's cooking holmium, which is element HO, with carbon which is literally part of the furnace. It's the carbon that's lining the furnace to hopefully make HOC2, because HAWK TUAH. To test it, I'm trying to do some stuff with copper sulfate, but it's actually green because I used all of this glassware before and haven't cleaned it. So, predictably, nothing is working, and chemistry is hard. Hello, 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 hello. Alright, so, I mean, why isn't this working? There's just all this other junk in it. So much junk. You don't want junk. Alright. Let's try and add more water and just do the exact same thing again, because Einstein said stupidity is doing the same thing over and over again. And I'm stupid. And now the microwave goes off. Perfect timing. So now, I take off. Oh god, it's glowing like crazy in there. I take this off. I put it over here. I hold my phone in a way that you guys can actually see it the correct side up. That says no food, right? Yeah. Things have occurred in this furnace. That's too hot. I need the hot stuff gloves, which are currently falling on top of the radiator, which is bad. I mean, I suppose of all the gloves, the ones that are rated for heat would be good to fall on the best ones to fall on the radiator. But like, come on, okay, come on, get in there. That's good enough. It's not good enough at all. Well, you can at least kind of see. How am I so bad at the things that I do? There we go. I'm in the glove. All right, now. Oh god, it's so bright. I don't know if you can see. Look, this is just the top of it. It's so bright. Okay, we're gonna put that upside down. This is nuts. Nuts, I say. Oh my god. What have I done? Oh, it's all cracked too. Yay. There's our holmium. Ow. Fuck. What is transpired here? I see there are chats. I will read them in a second. What horrors have occurred in this place? What happened? What happened? Okay, we'll just leave this to cool down. Then we can inspect. In retrospect, it probably isn't a great idea to have the hole in the bottom. It'll be fine. It'll be fine. It's really hot. That's bright. The sun in your microwave. I know. It literally like looked like the sun. I don't know if you can hear it crackling, but it's crackling as it's cooling down. Yeah, that was insanely. I saw the thumbnail. What the fuck? Yep. The element holmium is HO, and there's some of it there which we're trying to mix with carbon. The black stuff in the walls is carbon. And according to some sketchy scientific papers, it should form Holmium Dicarbide, which is HO2, which is the HAWK TUAH. Hell yeah. I saw you said HAWK TUAH was going to go boom, and when I arrive you say everything is starting to go wrong. Imagine when I feel it rhymes with bread. Surely it isn't dread. Surely it's it's red. You're feeling red because we're gonna make some red precipitate, which is gonna prove, which is what we're trying to do with the copper oxide stuff. Surely that's what you meant. What's this? It's a different color. Okay, so we definitely made some holmium oxide, because I'm pretty sure that right there, the little, you can't see shit. That powder right there. I cannot aim this camera for the life of me. Oh, that's because I'm holding it upside down. It's so hot. How is it this hot? Sheesh. That powder stuff, that yellow stuff, I believe is holmium oxide. The question is, did we actually form any of the carbide that we were trying to form? Or did we just make a cool oxide? The answer is, I don't know. But the Hawkside, I have HAWK TUAH ingrained into my mind, imprinted and forged onto my very brain. Don't go HAWK TUAH kaboom, bro. I just met you. We'll see if we get to kaboom. Right now, it looks like we made the oxide, and that's about it. Which, I mean, kind of makes sense. We are, you know, all of the actual papers, like, do this in a furnace filled with inert gas, and I'm just kind of praying. I have a couple other ideas. They're all bad, but we can try stuff. What I do want to do, before we try my bad ideas, though, is I have a UV flashlight, and the oxide might glow under UV, which would still be cool, and kind of be a fun consolation prize, you know? Even if this whole thing turns out failing. So I'm gonna go turn the lights off and see what we can do. Let me get gloves off first, though. Because I have 2 layers of gloves, glovity gloves, which is kind of bad. Because sometimes I only have 1 layer, and sometimes I have 2 layer. But it's fine. We'll be fine. Safety third. Things glowing under UV light first. Now I can't see shit. Fortunately, I have a flashlight. Wow, how convenient. All right. So now. So there we go. This is. What the heck? This. There it is. Now we got to try to see if we can see it under UV light. That's not UV light. That's UV light. Maybe very faintly. Maybe very, very faintly. Not really. I mean, this is not a very good UV flashlight, so it just looks normal. It's very sad. I thought at least, like, in person I can kind of see a glow faintly of a different color, but not really. God damn it. I thought I would at least get some cool fluorescence. This really is not going well. Oh well. At least other stuff looks kind of cool, and everything looks cool under UV light. Not really. Maybe just nothing. Is that? We'll just look at random stuff under UV light now. Oh well. We'll check again. I don't know. Maybe it doesn't do that when he did. But I would really, really expect the oxide to fluoresce under UV light, and there's no way that's not the oxide. There's definitely no way that's all the carbide. If that's all the carbide, then we've done a good job, which is unfathomably unlikely. So let me stop blinding myself and go turn the lights back on. Alright, try not to step in the puddle of reagents that I spilled. Alright. The lights have returned. You should learn alchemies in YT videos. It's funnier. I mean, it is fun sometimes. Chat, should I study chemistry in college? You should. I promise it's not this bad. It's not this sketchy. Oh, hey, look. Some of our copper sulfate kind of dissolved. Yeah. You do actually. I'm doing chem now. I switched. I used to do physics, and then I don't know. Physics is it. I don't totally hate it. It's just not my thing. Like, physics is so there's like the two sides, right? Theoretical physics is all math, and it's a ton of math, and it's heaps and heaps of math. And then when it comes to like chemistry, it's a lot more. It's just different. Like, a lot of the experimental physics is like there's one number, and you're trying to observe, you're trying to find out the value of one like constant or number or something really, really precisely. And chemistry is more like you're trying to like come up with this reaction that can work. And there's a lot of overlap and stuff. Zeno, when you're turning lead into gold. That is a thing. Physics is more theoretical, right? there's both sides to it, because there's like theoretical physics and experimental physics. There's definitely more theoretical physics than there is theoretical chemistry. So physics, like, both of them have both parts. It's not necessarily that the theoretical side of, it's not like physics as a whole is more theoretical. It's that there's just less of the theoretical part, if that makes sense. Like, there's like there are theoretical chem people who are doing just as much crazy math as the physics people. There's just less of them. Nah, physics is something else. Yeah, I don't know, it's hard to explain. Like, I think you should, honestly, I think the best thing to do is, like, take some classes in different areas that you're interested in and try to, you know, poke around to figure it out. I was originally going to be CS, and then I was like, actually, I like physics, and I was like, actually, I like chemistry, right? So I think the most valuable thing you can do is sort of poke around. How the fuck do people make these papers, or do they just do random shit? There are some papers that are random shit, but a lot of times it's like, sometimes there's really, really cool papers. Yeah, I believe I understand. Yeah. I don't want to spoil too much, but I was just like reading papers and stuff, and I came across a chemistry paper where they made, remember when it was a thing a while ago? Honestly, true, that's why I want to be undecided. Yeah, I think it's really valuable to be able to poke around and learn. There was it was like, remember when Nile Red and like a bunch of YouTubers found that one paper that was like making transparent wood, and then everyone started making transparent wood? And they were all doing it by the same method, which was basically remove the lignin from the wood, which is like it's the part that keeps wood from being transparent, more or less, and replace the lignin with some kind of like epoxy resin. That was the method that everyone was trying to follow. And I don't know, it was fine. It was really cool to see. But I found this other paper that was super weird, which was dissolve the wood into like this bizarre solvent. They came up with there's this thing called a deep eutectic solvent, which is a very like non-traditional weird solvent. So yeah, it was dissolve the wood into this solvent, and then like spin the dissolved wood into fibers, so that you're like remaking wood fibers from the original wood. So you take the wood starts as fibers, then you dissolve it into a solvent so it's not fibers, then you spin the solvent so it is fibers again, but it's like nanoscale fibers, and you can cast them into, like, you literally, like, it's like casting wood. It's such a weird, cool process. And so I don't know, maybe I'm in the process of figuring out how to do that with junk I get from Home Depot. Hopefully I don't have to bike in the snow again. But yeah, there's insane stuff. And so that's like one class of papers, which is very common to like materials and stuff, right? It's like, here's this cool thing that we made. A lot of other chemistry papers are like, here's some quality. So this is more like the physics side, right? So there's some interesting chemical. People will be like, okay, well, how does it behave in this circumstance? And we can do simulations and stuff, or, you know, do things experimentally. What is, like, you know, we have different ways of characterizing molecules, you know, especially like there's a lot of papers are just like the thermal parameters of like the thermochemistry of blank chemical, right? So if you want to predict whether a reaction will just like occur spontaneously or not, or whether a reaction will like produce or take heat, whether it will like produce heat and get hot, or take heat and get colder, that's all like thermochemistry stuff, and that's something you have to figure out experimentally. So there are papers that are just little, you know, cute little papers that are just like, we figured out all of the thermochemical parameters for like this random set of chemicals, and then other people can use that to do stuff. So they range. There's a huge range of like spectrum from like, we're observing this like, you know, quantity of some chemical to figure stuff out about it. Even farther than that, it's like, you know, we're simulating to try and figure out what's going on with some chemical, and slowly you work towards things that have, you know, I guess, closer to like application and stuff. So the transparent wood paper was like a materials paper that was very, very much closer to application. But, you know, you sort of work through these things, and every step depends on the other, and it's amazing. It's amazing. Like, that's what's really cool about science, is you end up just like pulling things from totally random places that no one would have predicted. Right, the people who first discovered this like weird solvent system would have never imagined you could cast transparent wood out of it, right? But eventually we just, you know, tried stuff and explored the natural world, and we figured out, oh, that's a thing you can do. And yeah, it's little piles on the human knowledge, and part of the fun is that you never really know where that's going to end up. But let's take a look at does the oxide look the same? More or less, yes. It does look like the picture of holmium oxide on the Wikipedia page, so... That didn't really work. We do have the copper sulfate, but the copper sulfate is kind of useless if... Like, it's useless to test for HAWK TUAH if we don't actually make any HAWK TUAH. So, It's time for Plan B. It's time for Plan B. What is Plan B? Well, Plan B is to cheat. So normally, I mentioned this is done under inert gas. Like, people love to talk about argon. Everyone loves argon. Why is argon so great? It's the same reason it's great for welding is more or less the same reason it's great for chemistry. It's just a gas that's heavy, and it doesn't react with almost anything. You have to really, really try to get argon to react with stuff. So what you could do is, even if you heat something up, normally if you heat, like if you did what we did, right, you heat up holmium and carbon in just an open atmosphere, you saw what happened. The holmium just immediately oxidized, and the oxygen just out. To test, you got to spit on that thing. You may actually make a good point, because here's the thing. What we're going to end up testing for is acetylene, and acetylene is formed when HAWK 2, when our HAWK TUAH chemical reacts with water. Spit is mostly water. I could do that. I don't want to. But I could. Alright. Oh my gosh. Okay, sure. We'll do that. We'll spit on it. And if it starts bubbling, if we see acetylene, then either that means there's unreacted holmium, or, which is the thing, the reason we need all this extra chemistry and, junk from Home Depot and making things that go boom, is because unreacted holmium also reacts with water. Both HAWK TUAH and unreacted holmium metal react with water to form like different things. One of them forms hydrogen, which is we don't care about, but our HAWK TUAH chemical forms acetylene, which we do. Can I just say you have the exact voice I imagined based off your avatar? That is really funny that you say that. I appreciate it, I guess. I don't know. I've never liked my voice that much, but we press on. Hello, Julio Gomez. Sorry, I'm not sure exactly which way the J goes. We're trying to make HAWK TUAH, and so far all we've done is oxidize holmium into holmium oxide, which is fine, I guess. And holmium oxide, I should add. Another fun little science tidbit. Holmium oxide, which is, what the fuck? Oh, you can't see it anymore because it's so dark. There we go. It's right there. It's right. Fucking hell. It's right there. Holmium oxide it has like a very, very, so I mentioned like the lanthanides are really useful, the rare earth elements, of which holmium is one of them. They're really useful for, like optics and stuff because they absorb light specifically. Holmium oxide has a super duper sharp peak where it absorbs light. And so it's used for it's actually used as in like a solution for optical standards because we know exactly where that peak is. That's a super duper sharp, well-defined peak. So we can use that to like calibrate instruments and stuff. So holmium oxide is a little bit of a fun chemical, although I'm mad that it doesn't glow under UV light because I kind of thought it did, but I don't actually know that for sure. I just know that most of the rare earth elements do. What if it goes both ways? Most people don't. I don't like mine. Yeah, it's complicated. I'm not sure what you mean by what if it goes both ways. Let's see. So the copper sulfate actually did kind of dissolve now. Or wait, that's excess copper sulfate. We'll add more so we actually have a decent solution to that. Let me put gloves on. Wait, why am I... I'm so out of order. I don't know what is even happening. Okay, so let's forget about the chemistry there. Forget about the Home Depot chemistry. What we need to do, since I don't have argon, I don't have a proper, sealed inert gas furnace to run oxidation, what we can try doing is basically just like packing it. That was a bad joke based on something you said, don't mind, lol. Okay. I'm sure it wasn't a bad joke. I'm sure I'm missing out, but... Alright. What we basically want to do is just protect it from air. So since the reactants are solid... Anyway, I'm convinced there's too many elements. Every element deserves to be loved and cherished. There's, you keep getting me to bring up, like, side video things I'm working on. There's an element, actually a particular compound, but mostly an element, that a certain very famous chemistry YouTuber, probably like the second most famous chemistry YouTuber, was like, this element is stupid, this compound is stupid, I can't do anything with it, it sucks. And so I may be working on defending that poor bullied element by doing cool stuff with it. But we're getting there, That's another in progress video. But these things take a long time, and a lot of planning, and a lot of reading papers. All right, so what we need to do is somehow pack it underneath something that will be mostly inert. What we can do... Wait, I have a horrible idea. Oh, do you want to hear my horrible idea? If I put sugar in the microwave furnace and blast it at like thousands of degrees, it should decompose into just carbon. Is that... I think that's how chemistry works. It'll make a bunch of weird gases, but it's probably fine. We're just burning sugar. So what I can do then is I basically just need to make like a layered structure where at the bottom we have like carbon, at the top then on top of that we have holmium, and then surrounding that to keep air from getting in, we have something. I need something that will be mostly inert, and so actually sugar isn't a great choice. But I don't know what else I have that I could use. Normally you use sand, but I don't have any sand, and I don't like sand. It's nasty and it gets everywhere. So I have plaster of Paris. I wonder if that would work. Maybe. I'm too nervous. I'm a little nervous to try that. I could just here. Let's do the same thing and just put more carbon on top. But I'm too curious to skimp out. I really want to find out. Does burning just freaking burning sugar give me carbon? Because my intuition tells me that yeah, it would. Why wouldn't it? Of course it would. So let's give that a shot. This is so bad. Okay, let's use these gloves now. I'm definitely mixing gloves and stuff, but at this point, I'll wash my hands. Nothing here is that bad. Okay, so we've got our microwave furnace with our holmium oxide. I can pour it out into like a little filter paper or something. Let's do that. The world's crudest, worst holmium oxide product. Why isn't it coming out? I don't want to bang my furnace too hard. Alumina dust and stuff, but oh, a piece of carbon just came off. Wait, that's a holy crap! Happy accident moment. Oh shit! Fuck. Look. Can you see that? Look what that is! A little piece of carbon graphite broke off from my furnace. So normally your furnace breaking into pieces is bad, but in this case it gives me a source of graphite that I can just nicely break up and use. That's fun. So we don't actually have to burn sugar after all, though I'm still tempted to try it. Scientist Anakin, calm down. Yep, that's what I was going for. What we can do is crumple up the graphite to just get graphite powder, and we'll use that to plug it. So, hello Alpha Core AI. Hello Shorted It Out. Welcome to the stream. So what we're gonna do is at the bottom we'll flip it around. We'll do a little flippity flip. Flip those pancakes. Hawk Tuah, flip on that thing. Flip that thing. It doesn't really work. Then what we'll do is we'll have a layer of holmium metal on the bottom and carbon on the top, or graphite. Graphite on the top, and that will seal it. Not a loss. Yeah, I don't think it's much of a loss either. It would probably just make a bunch of smoke, and it's not exactly what we want. All right, let's do this. So the only caveat, how do I do it? Ha ha. Ho ho ho. Ho ho ho. Let's move the sketchy chemistry bucket out of the way and try not to spill anything, even though I'm probably going to end up spilling everything. So let's take you out of the way. Buckets. We love the sketchy chemistry bucket. Thank you, Target. Cook that thing? Yeah, cook that thing. Turning graphite into graphene 24-hour stream. Making graphene would actually be a fun video. I'm sure other people have done that like on YouTube before, and I don't know, I like doing like weird new things rather than things that like, you know, other bigger channels have already done, but that could be fun. Smoking that Let's alright, let's make our little assembly here. Again, this really should not be possible, but I'm trying it anyway. So yeah, there's my all cracked to heck furnace. How do I want to do this? Can I crack off more of it? I mean, if cracking is good, can I just intentionally stab it with a pencil and like crack it? Who says I can't? Yeah, yeah, yeah. No, okay, it is actually kind of hard. I guess it's a good thing. I guess it's a good thing. Yeah, okay, that's not working at all. Okay, but we do have our little piece here, which is, yeah, it'll be fine, it'll be fine. Okay, so let's, glove. Glove, the glove. This is all the chaotic energy, okay? That's the inside of the glove, which is what I'm allowed to touch. Pro chemistry tip. You want to touch the inside of the glove, not the outside of the glove. Generally the vibe. Okay. So let's just take our aluminum pieces, and what we're going to do is shove them into the cracks in the furnace. This is a bad idea, just to be abundantly clear. This is a bad idea, but I'm going to do it anyway. They don't even fit in there, but I'm going to smush them in there anyway. Oh, you can't see this at all. You just have to trust me that I'm doing this. This might not be the most well-produced stream, but at least it's... hopefully it's at least authentic. Glue sounds like Russian. I mean, that's fair. It reminds me of, like, Glühwein, which is it's like the German, like, mulled wine. It's really good. You have it around Christmas time. It's delicious. Delicious. Alright, so that's that. That's our little tiny bits of stuff, and now we can try to... I'm literally wearing my gloves like this. Don't repeat after me. Okay. So now, we just try to cover it with graphite, which we get by crushing the piece, and that doesn't really work at all. So we try to rip off a chunk of graphite, which actually does kind of work. But it's still hard because it turns out that graphite is not as brittle as you thought it would be. But we press on. I'm not giving up this easily. I need to make my HAWK TUAH, even if it means destroying parts of my furnace. It's for the HAWK TUAH. We do it for the HAWK TUAH. Get HAWK TUAH. Fill up that thing. Yeah. Again, this is not what you're supposed to do. I'm sure anyone, if there happens to be anyone in chat who's actually a real material scientist and actually makes this kind of stuff, I'm very sorry. I don't have argon. I would use argon if I had access to it. I pinky promise. Not literally just shove it into the walls of my furnace with broken pieces of furnace. Yeah. There we go. We're almost there, folks. We're almost there. You know you can't really see this. Okay, that's not good enough at all, but we are going to do it anyway. I'll do one more little bit. Get crunched in there. Hell yeah. Alright. Alright. Now, keep this stuff off. Back into the microwave. I have not played CSGO ever, so I regret to inform you that statement is false. Yeah, HAWK TUAH explode that thing. Exactly. Let's now put this in the furnace, which hopefully all the graphite doesn't just fall out. I kind of didn't think of that. Yeah, it'll be fine. What if I did this? What if I put it in sideways? This is the worst thing I've ever done by such a long shot. Can I put my furnace in sideways? This is so bad. This is gonna spin. Oh. HAWK TUAH, rotate that furnace. It's like the get rotated idiot, but with the furnace. And it's not actually the furnace that's the idiot, I'm the idiot, but let's just see if this works. This is a bad idea. Don't do this. But I'm going to do it anyway. Because internet. Let's do 6 minutes. It's not falling over. It's a good sign. Chemistry. Yay, chemistry. Yeah, you can see little bits kind of glowing on the top. We'll just leave it going there. And in the meantime... Oh, wow. Okay, wait. Let me get it so you can see the... Damn it, how am I... Yeah, glowy. The glowy. So hopefully, that will do a very crappy job of protecting it from oxygen. But it will protect it from oxygen a little bit, and we'll get some carbide. If not, then I spent all the time biking to Home Depot in the... I spent all that awful effort biking to Home Depot in the snow and cold and wind for nothing. I mean, not nothing. Like, there are plenty of projects that I need hydrochloric acid and shit for. That I need ammonia for. It's just... Why? Pain. Let's at least try to do the thing with the sugar, because even if we don't actually make the acetylide, it'll still be a fun little thing. We can prove that we didn't make it. We can prove it. All right. If you're a scientist, it's better not to play CS anyway. Well, I didn't play CS the game, but I am getting like a minor in CS, and in high school, I was not like science at all. I was all CS. You can change. You can hop around. Microwave and pray. Exactly. That's the strategy here. That's how we do science here at Xenotime Laboratories. Microwave and pray. Alright, let's get out the awful blocks and try not to spill corrosive shit all over my... It's more toxic than corrosive is the problem. I guess that's not really very comforting. The awful, shitty, sketchy chemistry bucket. No, I know you meant Counter-Strike. I was just doing a bit. I was doing a bit. A bit of a bit. Which actually, computer science style, right? Bits and bytes. If you make 8 jokes, then it's a byte. Alright, let me, try to figure out which gloves I had. There we go. That's a glove. And that's the outside of the glove. Oh, that's a hole in the glove. Ruh-roh. CS is fun. Did make me a femboy though. Which CS? That's the real question. I think I know, but which CS? Oh, both meanings. I see. You answered my question before I read it. All right. Oh, I have these gloves. See, I'm all up to date on safety and safety and safety. I know which gloves I'm using. Wait, fuck. Yeah, okay, we're good. This is the safety standards that we have here at Xenotime Laboratories. Our furnace is sideways and also broken, and also the top is on backwards because it's broken. So my understanding is the sun in your microwave will HAWK TUAH a chemical you need for other projects. So we're starting with just HA and K, right? Holmium and graphite. And the microwave should turn it. The microwave should turn that into HAWK TUAH. The HAWK TUAH is just for fun. Literally just for fun. They're saying, you'll see in a second. If you're wondering what's going on with the sun, then you'll see it gets very bright in there. It's amazing what microwaves can do, honestly. It's so cool. Safety third, exactly. This glove does not have a hole in it. That means we're all up to doing safety, and we have all the safety. So much safety. Imagine being this safety. Now, because the other glove didn't work, I have to try to open this with one hand, which, when it's the child-proof thing, is difficult, and it doesn't really work. Did that go through my gloves? I don't think so. Whatever. I'll put the hole in the back. Sure. Now I can do this at least. Why is it so hard to open these things? There we go. Now I don't need this stupid fucking glove anymore. Well, I can't use it to press the button to make the microwave go longer, because everything seems fine. Everything's fine. Everything's fine. We're doing fine. Add a little bit more copper sulfate. He will tuah into the chemical or something. I'm not a chemist, exactly. As an Indian electrician, I approve your safety. Oh boy. Oh boy. Hawk tuah, stir that thing? There's only... Oh, I can use the shitty... This is low enough where I can use the shitty piece of 3D print as a stir bar. Right, this is the stir bars that we have. And it still doesn't really reach all the way down. Fuck. Oh, there we go. There we go. Chemistry. 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 Chemistry! Is it getting more blue? I don't even know if it's getting more blue. Okay. That might have been just a huge failure, but whatever. That looks like it was just a huge failure, but maybe it's a little bit more blue. It's hard to say. I think it's time. Time. It's time. What is it time for, you ask? It's time to add some sugar. It's sugar time. Now, fructose is the two most common sugars are fructose and glucose. Fructose is fruits. Glucose is also in fruits. Sugar chemistry is actually way more complicated than you think. But fructose is what's called a reducing sugar, meaning it reduces things. Which is, in this case, it will reduce our copper. The copper 2 ions, meaning they're bonded to like two things in this little solution. It will reduce them to copper 1, and it'll make copper 1 oxide. As a guy soldering 120 volt compressors right now, safety is made up. Well, good luck soldering your compressors. I don't know if I can say I approve of your safety, but I can't say I disapprove of it. So, good luck with that soldering job. All right, actually, it looks like the microwave is almost done. We'll leave it. Let's just keep it going until it explodes. That seems like a safe thing to do. Okay, now where is... there's my sugar. So, there's also excess copper sulfate here, though, and I need to get rid of the excess copper sulfate. I mean, I don't know if I really do, but I would like to. So let's... how do I want to do this? How do I want to play these games? Let's... frickin' frick. This is why you generally have more than 2 pieces of glassware in a chemistry lab. My yellow 3M earplugs are enough. Yeah, alright. How do I... Because the thing is, this didn't dissolve completely. And the product I'm trying to make is going to be a solid. So... I guess I can just pick out the crystals manually. That's kind of sketch, but it'll be fine. So let's go ahead and pour some sugar into our solution. Chemistry. Now that sugar is contaminated with whatever's on my glove, but it's fine. And do we see a red precipitate? I don't see a red precipitate. That's bad. Do I need to make it basic? Do I need to add my lemon-scented ammonia? Let's... what a disaster. Let's leave this... Okay, let's, we're going to check the furnace. Here's what I'm going to do. We're going to sequence of events. First, we'll stir this a little bit, and we'll leave it to sit. While this is sitting, we'll check the furnace and see what's actually going on that front. Then, after that's done, we can come back to this. We're just, like, alternating back and forth between the microwave stuff and the other stuff. Oh, no, I'm just reaching into it now. I'm just touching it. Whatever. Goodbye, glove. Let's check in on the microwave side now. So, I know one of you wasn't quite sure what the sun was. Chemistry, also double glove, please, this hurts. And could hurt you. It's alright, it's alright. The copper sulfate solution is, honestly, I wish it was my fucking model. Again, nothing's that bad, and it's alright. I know I definitely don't have good safety, and I'm definitely, but like I'm not being, really stupid. I know the risks, and that's like the most important thing is knowing the risks, I think. All right, let's take a look at the microwave though. How's the microwave division of Xenotime Laboratories going? Let's see if that's... Yeah, so you can see that rather bright light. Just a little bit bright. When you put these gloves on, so that I can touch it without obliterating my handsies. And we'll just have to see if this works. Honestly, I don't even know if, even if we can't test for the HAWK TUAH, it's alright. Even if it was technically a waste to go to Home Depot in the middle of the snow, at least it gets to be a funny little story that I can tell on stream, you know? Sometimes things are just like that. And my glove is still not on. Now we peek inside. You ready? It's hot in there. Oh. Okay, you saw nothing. You saw nothing. Is our HAWK TUAH in there? I don't know. We'll let it cool and see. Yeah, normally you touch the outside of the furnace, not the inside of the furnace. Pro tip. I really don't like doing that, but we'll leave it up there for now. There we go. Average things to do in a dorm room. Microwaves, man. They're far more powerful than you think. Oh wow, is that a crucible in your microwave? Yeah, so this is, you can just buy these. This was like $20. It's called a microwave furnace. And what it basically it is literally just like a insulation, alumina insulation, that you're using as effectively a crucible with, you know, a hole in the top to let steam out. Normally, again, I'm using this totally the wrong way and upside down. But the thing that makes it work is that there's a layer of graphite. There's that layer of graphite around the edge, and like as I mentioned, graphite is really good at absorbing microwaves. In our case, that's where like the process ends. The graphite gets really hot. We're reacting stuff with graphite, so you know our reaction will get really hot and everything's fine. The way the microwave furnace is intended to work is the graphite just sits there on the outside. It gets so hot that it radiates heat as like infrared, and it's that radiated infrared heat that actually like heats up the stuff in the middle, what you're trying to do. So we're doing like a direct process where we're trying to heat a graphite-based reaction mix, and so microwaves directly will heat graphite, and we're more or less just using the furnace as like a crucible, like you said, as just insulation. But the sort of intended use of the furnace is like indirect heating, so is to have that graphite heated indirectly. So graphite is you know, microwaves hit graphite, graphite absorbs the microwave, gets really hot, and then it radiates that heat out to whatever you have in the middle. It could be a, you know, glass or something. The reason my microwave is obliterated is because I tried to do it with salt, and it formed a bunch of corrosive sodium oxide. The yellow flame says there's no flame. There was I don't know what you were talking about. My glove never caught fire. There was no flame whatsoever. Although wait, actually, I didn't realize your PFP is like your profile picture is a little bit of yellow flame. If that's what you mean, if you mean you say make chaos take the world, then sure, make chaos take the fucking world. Hell yeah. My streams definitely have chaos. They don't have many things, but chaos, they got that on lockdown. All right, let's take a peekity peek, and see what we got. Wait, that might actually be good news. I can't really tell. Let's see. Let's move the chemistry bucket out of the way and let this cool a little bit more, because again, it gets to like almost 1,000 degrees in there. So if you're using the microwave furnace normally, then it gets to like a little under 1,000 degrees, I think. But if you're doing the direct process, like graphite in the microwave can get incredibly hot, approaching like 2,000 degrees. So we'll just see how this goes. Again, the actual process to detect this doesn't seem to be working, so I might just have to kind of go by eye. But you know, we'll see. It actually might kind of work. And here's okay, never mind. Yeah, I lied. It's probably not gonna work, but whatever. Let's move the chemistry bucket out of the way. That's what I was doing. Wait. Is the acid spilling on my floor? The acid is... I have amazing good news. The acid does not appear to be spilling all over my floor. Alright. Let's bring this thing down. How hot is this now? That's still a little bit hot. I don't know if I want to set it on. I don't know if I want to set it on a cardboard just yet. But what I can do is get a little filter paper thingy to scoop it out on. So let's do that. That seems the same-ish. This is contaminated fructose. Why would you label things when you can pretend that you have a functioning memory? Alright. Alrighty, right. Plop it in there. That's going to be the plan. So I've got... You can see it doesn't really look like much, which is good. If it looked like much, that would mean that there was oxide, and we don't want oxide. So somewhere in that little crack is our stuff. You can see, actually, there is... I swear, I cannot position anything in this camera. There we go. The yellow stuff, I believe, is holmium oxide. But let's take a little peeksies and see if we actually made any. Because it got very hot, and in theory, we should have. Can I prove it? It doesn't appear like I can prove it, but oh well. I was kind of skeptical of this working, in the proving part working in the first place anyway. Okay, now I need something to scoop it out with, though. And this is still really hot. How is it still this hot? It's almost like it was more than 1,000 degrees a little bit ago. That would be so crazy. It'd be so crazy. Alright. I could use my X-Acto knife. This is a bad idea, but it is an idea. And I don't really have another one right now, so... I guess that's what we're doing. X-Acto knife time! Let's fucking do it. Alright. This is impossible to orient my arm. There we go. Maybe it did oxidize. It's hard to tell what's going on in there. Get out. Get out, you little guy. I'm just going to crack my furnace in half at this point. Oh, come on. I don't want to really cut the alumina either, because alumina is not great to breathe in. So this is actually a terrible idea, and this is actually really bad, and the X-Acto knife was really stupid, and fuck. I'm kind of an idiot. God damn it. Why am I so dumb? Why am I so dumb? Okay. Okay. Let's just get all that out there. It looks like we got most of the stuff in there out there. Most of the stuff that was in there out of there anyway. Let me go ahead and look at it under flashlight. Yeah, I don't see much. Alright, so we might actually have something here. I'm going to go put that back on top. And I'm going to go take off these gloves. Here's where we're at. This might have actually kind of worked. Do you have a mask? Nope. Also keep yourself hydrated. Yeah. I mean, this space is ventilated, right? I have ventilation going on. And I didn't really cut it that much. I just, put my thing in it. But it's it's probably fine, but that was bad. I shouldn't have done that. I really shouldn't have done that. Let's take a look, though. Let's take a look-sees. So this is what we got. And most of it just looks like either carbon or the oxide. But what's this? I don't know if you can see that. Let me try to point at it without actually touching it. Oh, come on. Stupid fucking camera. Some of them look like the oxide, but there's little bits of something else on their surface. There's no red precipitate, so our test that will turn it into things that go boom is definitely not happening, but if I can get this in focus, and I can point at it, then that little bit, that looks like mostly oxide, but there's also something else, and I'll have to take a closer look. But here's the thing, all of this is oxide and carbon, right? So actually, I should be able to more or less... Yeah, exactly. I do see a third color. Exactly. Now, I don't know what color HAWK TUAH is. I know that HAW4K7. There are also higher holmium carbides that you can form at like other temperatures. I know that particular one, I believe, is gold. I don't think I've reached high enough temperatures to make it. I don't think that's what I actually have. I'd be amazed if I have that. But or not high temperatures, sorry, high pressures. You need high pressures to synthesize that, I think, if I'm remembering right. I don't think it just forms spontaneously at such low temperatures. Again, like, you know, that 1,000, 2,000 degrees Celsius is not normally low temperatures, but yeah. And then I guess what we can do is spit on it and see if it bubbles any gas. Because, again, credit to Object in the chat for making me realize that kind of obvious fact. If it reacts with water, if the way we can test it is by reacting it with water, and we're going to assume that anything that's just holmium oxide will be anything that's just holmium metal that would have normally produced hydrogen and messed with our results, it looks like it's just covered in oxide anyway. So that shouldn't bubble any gases. We shouldn't have to worry about that hydrogen gas, which is the whole reason we needed all the other chemicals and the explosive stuff. So it's not a very good test, but it is a test. Just spit on that thing, which is just too perfect, and I probably should have realized that myself. So let's take a little piece out of it, spit on it, and see if it bubbles gases. Let's frickin' do it. Now let me get a little surface to do it on. All right. Put this here. I want to be able to actually see this, so I don't want to have it so far down. And I will, freaking frick. How do I want to do this? How do I want to not get my phone contaminated? Oh, I'll use the pencil case. There we go. Perfect. Now the pencil packaging is contaminated, but my phone is safe. Because safety is the most important priority. There we go. That is not working at all. Let me do that. That is also not working at all. Let me do that. That is kind of barely working. Hell yeah. Hell yeah. Okay. Now let's pick out a little piece. Do I use my glass glove? Is this the honor that my last remaining glove gets? To HAWK TUAH spit on that thing? Let's do it. The last glove. The honored last glove. Alright. So I'm just going to pick out a piece of what we suspect. What we suspect might be some HAWK TUAH. It's like green. Whoa. It is actually really cool. Alright. Place this down here. That is not the right side. That's the oxide side. It is actually promising that it only looks like it formed on one side, too. So that little speck right there is our suspected HAWK TUAH. Can I zoom in? Video source. Oh no, that's not going to do anything. Video. Can I zoom? I can zoom. Holy shit. I didn't realize I could zoom. Zoom. Wait, let's zoom out. Zoom in. Oh no, I can't actually zoom. Okay, never mind. No zoom for you. Unless it did. Wait, it looks like I might have. Ah, it's as good as we'll get anyway. There we go. Alright. It's time for the moment you've all been waiting for. It's time for me to spit on that thing. I hate that I'm doing this. I hate that I'm doing this so much, but I am. I missed. I missed again. This is so hard. I'm just spitting on my microwave. Jesus fucking Christ. Okay, can I spit on a piece of paper and then touch it to that? Does that count as spitting on that thing? I think that counts, right? Surely that counts. Yeah. Everyone in chat is saying yeah. There's 10 million people in chat and they're all saying yes. Sounds great. So I'll... Okay. I've successfully spit on this piece of filter paper nonsense. And now... Now we ooze a test. This is so gross. Does it go away? Does it bubble acetylene? Does it do anything? We'll add more reagent. This is the worst. Oh, wait, was that a bubble? It's bubbling! Holy fuck! That is probably impossible for you guys to see. HAWK TUAH, spit on proxy and then ladder that thing. Exactly. It's HAWK TUAH via proxy. It actually bubbled a little bit, though. It's actually bubbling a tiny bit. This is the least scientific test ever. I have almost no confidence that the bubbling is actually acetylene. But look, I'm just saying, we did make HAWK TUAH. If we did make HAWK TUAH, we would be bubbling right now, and it's bubbling just a teeny bit. Let's see if I can get it without the proxy. That's close. I can't. This is the worst. I'm just spitting on my fucking microwave. Don't expect it to work. I know, the Strat was just burying it. It's life. That's life advice right there. When you have problems, just bury your problems. You don't need to worry about inert gas. Just if you have problems, just bury them, and then you don't have to worry about them being oxidized. It's great. It's just great. Again, I have no clue if it actually worked, but this is the most working that it could, given the fact that all my Home Depot chemistry failed miserably. So thank you, everyone, for tuning in to the worst stream of all time. Thank you to my last glove for protecting me and doing the honor. And thank you to the element Holmium for allowing me to make probably HAWK TUAH. I can't. There you go. There you frickin' go. Alright, as usual, if you have any questions, I'll be around for the last little bit as I sort of clean things up just for a little bit. If you have any questions, feel free to pop them into chat. And I will try to clean up this absolute massive mess that I've made in my roommate section of the dorm. Before he comes back. Oh my gosh, alright. Alright. Thank you all so much for coming. Thank you all so much for enduring this. I know it's kind of late too, especially in certain time zones. But HAWK TUAH, more like, heck yeah, it worked. Alright. Thank you all so much for joining. Is it bubble anymore? No, not really. It's fucking wild. Yeah, so that was. I mean, it reacts with water, which is what spit mostly has, to form acetylene, which is a gas, and any holmium should have been protected by an oxide layer. So there we go. Alright. I am going to end the stream. Actually, I'm not going to end the stream. I have an idea. Let's do a control. It's freaking science time. If we're doing science, we gotta do a control. Let's take one of the pieces that doesn't look like HAWK TUAH, that we think is just the oxide, and see if that bubbles. Will this maybe does this have a strong risk of disproving the fact that it's actually HAWK TUAH? Yes, it does, but it's science time. Well, now I believe this is when we put the 18+ tag in the description. Oh, come on. Okay, let's take... Do I need to take it out of the thing again? I want a piece of just holmium. Oh, right, I have it over here. There's actually looks like there's a bit of pieces there, too. It's just hard to say if it's that or staining, like, from the graphite. Because most of it was in contact with the graphite. Let's take this piece. This piece looks like it doesn't have much, if any, HAWK TUAH. And we'll do it by proxy again. I have more filters. There's no way I can aim it. Did you achieve TUAH? I think we did, but we're validating just to make sure, because science. We're here to do science, so we got to do a control. I hate this so much. Oh, I spit on my computer. Now we flip it over. We see. We get. That didn't work at all. Does it bubble? Do we get the bubbles? Very scientific test. Get off there. Oh wait, there does actually look like there is some carbide on the bottom there. But. Oh, maybe not. Maybe not. Maybe that's just carbon. Chemistry tips: don't spit on your equipment. Okay, let's do this. I mean, it definitely doesn't look like it's bubbling like anywhere. So, is that a successful control? I mean, maybe. Let's actually put it in a puddle first. There we go. Does it bubble? I hate this so much. Oh, there we go. There's some there. I don't see it bubbling at all. Yeah, get that. Move that over there. I mean, I don't see any bubbling. So, I think that means that we have successfully tested our control. And... fucking hell. We have successfully tested our control, and there does not appear to be any bubbling, so... I think we achieved TUAH. I think we achieved HAWK TUAH, and we spit on that thing. Alright, I'm gonna... Now for realsies. End the stream. Thank you everyone for coming and enduring this absolute maniacal nightmare. And if it somehow is still April Fool's Day in your time zone, then happy April Fools. Happy April Fools. Alright, bye everyone. Thank you so much. Thank you so much to everyone who came and stopped by. Have a good night. Have a good night too. I will be having a cleaning night. I will have a night of cleaning. And homework. I still have some homework. Can you believe that? How irresponsible am I? It's for the meme. We do it for the meme. Oh my gosh, what a mess. Alright, bye everyone. Thank you so much. See you. And oh yeah, I almost forgot. I will see you in no time. Thanks for coming to the stream. And happy April Fools.